Hi, it's Mr. Mac, and in this our third video on space, we're going to be asking the question, how do we measure time, especially when we look at particular phenomena from space?
This is Mr. Mac. He can explain things really well and is a lot of fun to watch. You can subscribe to Mr. Mac's Physics channel. You will find mathematics problems, science demonstrations, astronomy and space pics, physics calculations and simple explanations of advanced concepts.
So here is a picture of a clock we have on our wall, and it asks the question, how do we measure time? Obviously, we look at the clock and we can measure time that way, but how did that all begin when we're looking at phenomena from the universe? So what we're learning to do is to describe how we use phenomena from space to determine measurements of time. And we'll be able to describe how time has been measured from the perspective of Earth and elsewhere. Now, our day, as we've seen in the previous video, is based on the Earth's rotation. Here's a picture taken with a camera on my mobile in 2021, and it shows 3 stars of the Southern Cross and 2 pointers. They are very faint, and in the next slide I've enhanced the photo. So here you can see the 3 stars of the Southern Cross, the brightest 3. I'll circle them here. That's 1, 2 and 3. We can't see the others because they're not bright enough to show up in this photo. And here are the 2 pointers. And you can see that the pointers are pointing to the top of the cross, except the cross isn't upright as you'd see it in the Australian flag. Now, daytime is usually part of one whole day. And here's a photo I took of my shadow. When you look at the shadow, you can see that it's got sharp edges. And that's because the sun is so bright and far enough away that we can see sharp edges on our shadows. Of course, the sun is too bright to look at, and we never ever look directly at the sun because it can permanently damage your eyes. So our observations of the sun will be with our back to it, like I have, as you can imagine in this photo. Each day that we have is divided into smaller time units of hours, minutes, and seconds. And there are 24 hours from midday one day to midday the next day from our perspective. Here's an application called WinStars, and it's showing every hour what the daytime looks like. So this is about 5 o'clock, 4 o'clock, 5 o'clock in the afternoon. The sun is lowering, going down in the west, and you'll see that Mercury is in front of the sun, so you can't actually see Mercury. As the sun sets, the sky darkens, and we can actually see the stars, which are not as bright as the sun. And you can see as the stars are moving on, they move each hour. 130p McNaught Hughes is actually a comet, and it has an orbit of around 6 2/3 years. It was first discovered in 1991. But as you see, as the hours go on, this is 7 o'clock in the morning, the sun causes the brightness in the sky and the sky to turn blue. And you can see that in another video, why the sky is blue. If you look at the time on the top left-hand side, it says it's around 1400 or 2 o'clock in the afternoon, and the sun is again lowering in the sky as it goes on its daily journey. That's a useful app. It has the names of the constellations in green, the names of the stars in red, and you can see what happens in the night sky at a quick glance. Well, daylight plus that night time is the 24 hours. And the word day can mean lots of different things in different contexts. So what do we mean by day? In astronomy, we distinguish between a solar day, which is the time measured from noon on one day to noon on the next day, and a sidereal day, which is the time that the Earth or any other planet rotates once on its axis as measured relatively to the background of stars. This sundial shows the shadow pointing to 10 in the morning. It's actually 11 a.m. due to daylight savings at this time, adding an extra hour to the time. Hours, minutes and seconds. Here's a photo of a battery-powered clock. It's made to look like an old station clock, and it has Roman numerals around its face to mark the hours. It has a second hand, that's the very long, thin one pointing straight up to the 12, XII in Roman numerals. The shortest hand is pointing to V, or 5, and the long hand is pointing just below the 9, IX. Those three hands tell us the time. 12 hours for the day, 12 hours for the night. We would use normal digits around the clock, but here are the Roman numerals from I to XII, or 1 to 12. So how do we tell the time? On analogue clocks, the hands move at different speeds. The fastest is the thin hand, the slowest is the shortest hand. The second hand, the thinnest one, moves every second and makes one revolution in 60 seconds. The minute hand, or the long hand, makes one revolution in 60 minutes. And the hour hand, or the shortest one, makes one revolution in 12 hours. So in one day, the shortest hour hand goes around twice. So we read the time. It is 4:44:00. That is, it is 16 minutes to 5 o'clock precisely. Now, we don't know if it's morning or afternoon from this clock. The photo was actually taken in the afternoon, that is post-meridian, which is a Latin phrase for after midday, and we abbreviate that to PM. If it was taken in the morning, we'd call it ante-meridian, before midday, or AM. What does the Bible say? In Ecclesiastes chapter 3, verse 11, it says, "Yet God has made everything beautiful for its own time. He has planted eternity in the human heart. But even so, people cannot see the whole scope of God's work from beginning to end." That's from the New Living Translation. Everything in creation is beautiful. Quite clearly it says that. God has made everything for its own time. And the cycle of day and night has been observed from early times. The Bible records how each day has evening and morning, and you can read about that in Genesis chapter 1. The 24-hour pattern with daylight and nighttime is a cycle that was from the beginning and is caused by the rotation of Earth on its axis, as we saw in the last video. God made the moon and stars to appear at night. And this is the perspective of the writer, seeing that the sun appears to rise, but of course we know it's due to the rotation of the Earth. And 1 year is based on Earth's orbit. Now, what's this photo all about? This is a photo of me when I was 2 years old. And as you can see, the leaves on the liquid amber trees in the background have turned yellow. This occurs every year in the season of autumn, or fall as the Americans call it. In Genesis chapter 8, verse 2, it says, "While Earth continues to exist, planting time and harvest, cold and heat, summer and winter, and day and night will not cease." That's from the New English Translation. So seasons are the result of the yearly orbit of the Earth around the Sun and the fact that Earth's axis of rotation is tilted. 1 month is based on the Moon's orbit. Here's a photo showing a crescent moon taken on in 2006. There is actually also a planet next to it. As you can tell, the image is blurred from the handheld camera, and I'm suggesting to you that if you want to take better pictures, use a tripod, which I didn't at the time. On the right-hand side, you can see a picture of the full moon, and that was I took back in 2008. And we can spend time watching the moon over a month. In fact, the word month comes from the word moon. And you can see it change its bright part. The bright part is lit up by the sun. The moon itself does not glow. It simply reflects the sun's light. And the different shapes are called phases. Here you can see an animation from NASA showing the different sides of the moon, different shapes that it forms, as the sun lights up different parts of it. You'll notice that the moon essentially, if you look at the craters, continues to face us. So it's not actually the shape that's changing. The moon is roughly the shape of a sphere. But the sun shines on it from different angles from our perspective. And so we talk about the phases of the moon going from a crescent to a half phase to a full phase or full moon. So the moon's phases. Thanks to NASA, we can see how the sun lights up the moon on one half all the time, except during an eclipse. And we look at this relatively from different angles on Earth, even though we look at the same hemisphere of the moon, roughly. Phases are usually called new, first quarter, full, and last quarter or third quarter. If the bright part of the moon is less than half, it's called a crescent moon. If the bright part of the moon is more than half, it's called a gibbous moon. And the whole cycle lasts about 28 days. When the bright part of the moon is getting bigger, it's called waxing, and the same phase occurs at the same time wherever you're living on Earth. Now, what's an eclipse? I mentioned that in passing. This photo was taken in Dubbo in the central west of New South Wales in 2007, and you can see it's not a phase of the moon. You can actually see the shadow of the Earth moving across the moon. This is called a lunar eclipse. Here's another photo taken at Sutherland at night in 2021. Shows another lunar eclipse. It was a total eclipse showing an orange-red colouring due to the light from the sun going through the Earth's atmosphere. It's sometimes called a blood moon due to its red colour. Well, 1 week is another time-based, but it's not based on observations. 1 week is not an astronomical timescale. So where did it come from? In the Ten Commandments, God showed how a weekly cycle is important. In Exodus 20, it says, "You have 6 days each week for your ordinary work, but the 7th day is a Sabbath day of rest dedicated to the Lord your God. On that day, no one in your household may do any work. This includes you, your sons and daughters, your male and female servants, your livestock, and any foreigners living among you. For in 6 days the Lord made the heavens, the earth, the sea, and everything in them. But on the 7th day he rested. That's why the Lord blessed the Sabbath day and set it apart as holy." Now here's a picture that I took of my mum and one of my daughters on a trampoline in 2007. I think she's demonstrating what happens to space-time around a massive object in its gravity well. Albert Einstein theorized about time and space, and he suggested that time could be distorted by gravity, just as my daughter caused the trampoline to bend. More of that another time. So what do you know? Write down the meaning of each of the key words in the box above. What do we mean by the phrase solar day? Why do you think we have sharp edges to our shadows? Draw a diagram to show 2:55 p.m. on an analogue clock. Why do stars appear to go down towards the west? What are the causes of the seasons on Earth? And the cycle of moon's phases takes about 28 days. Research online to find out why our calendar has different days for each of the months, and can you design a better calendar? Here are the sources I used in making this video. So we've seen how we measure time in different ways according to the phenomena that we see around us in space. It asks the question that, what sort of technologies have helped us gain information from space? Well, that's in our next video. I'm Mr. Mac. Thanks for watching.